In this video for section 8.3, we're going to talk about how to find the sample size required to estimate a population proportion to a specified level of accuracy. And this is a formula that we're going to plug into by hand. The formula is here, sample size for estimating p. It's n equals z squared times p times 1 minus p divided by e squared. P is a value used to represent the population proportion, E is our desired margin of error, and Z is the critical value, which is given below. For 90% confidence, Z equals 1.645. For 95% confidence, Z equals 1.96. And for 99% confidence, Z equals 2.576. So that's the value for Z. We're going to choose that based on the desired confidence level in the problem. And the value for E, desired margin of error, is also going to be given to us in the problem. The value for P is a little bit tricky. It's the value used to represent the population proportion. Since we haven't actually done the survey yet, we don't know what the value for P that would result is. So we have two options to represent the population proportion. The first option is that we can use a value of P from a prior study or a pilot study. The second option, if we don't have a prior study or pilot study to look at, is to set p equal to 0.5. This would make 1 minus p also equal to 0.5, and this will give you the largest and therefore the safest possible value for n. It's better to have too large of a sample than too small of one. And as we talked about when calculating sample size for means, we always want to round up to the next highest whole number. Even if it's like a decimal like 0.1, we would round up to the next highest whole number. So let's look at example 8.7. A marketing research company wants to estimate the proportion of a client's customers who like a new television commercial. They wish to develop a 90% confidence interval estimate and would like to have the estimate be within plus or minus 0.05 of the true population proportion. Determine the required sample size. So this plus or minus 0.05, that's the value for E, or the margin of error. And we know that we want to develop a 90% confidence interval. So that tells us that my value for Z is going to be 1.645. So plugging into my formula, we have n equals z squared times p times 1 minus p divided by e squared. So 1.645 squared. Now in this problem, they're not giving us any pilot study or prior study to work with. So I'm going to set p equal to 0.5. And then 1 minus p, 1 minus 0.5, will also be 0.5. And I'm going to divide that by e squared. E is 0.05. And if I type all this into a calculator, I'm going to get 270.6025. And so this means that I need to survey 271 customers.